Next up, we have permutation for things that must be separated. In the previous video, we talked about things must be together. How can we not talk about things must be separated? But before we go into the calculation, let's look at one important feature between togetherness and separation, right? So on the left-hand side here, right? Suppose there are two red stars, all right? So it's simple. They are either together like this, or they are separated like this, right? Very simple. They're either together or they are separate. All right, how about for three stars, right? For three stars, they can be together like this. They can be separated like this, all right? But how about this? What if like two of them, they are together, but the third one is, out of the place. The third one is kind of like separated like this. All right, so if you have a situation like this, do you consider them separate or together, right? It applies to things that are more than two, right? For two, it's simple. It's either together or separate. For three, we have this dilemma, right? It can be some of them, they are together, some of them, one of them, or maybe some of them, they are separated. So in this case, it is neither separate nor together, all right? For the sake of discussion, what I'm going to talk about in this video is only for cases like this, all right? For cases like this, for things that are separate. In the previous video, we talk about things that must be together, all right? We only talk about these two cases, all right? For the final one, all right, we don't have a reliable way to calculate. There are three that maybe breaks into two, one. If there are like four red stars, it can be very complicated, right? So we don't have a simple way to deal with that. All right, bear this in mind. When we say things must be separated, we talk about this. All right, this is separate. This is not separate. All right, we do not consider the third one to be separate nor together. All right, it's neither. All right. So I think I will best illustrate this idea how to do the separation with a past paper question. Right. So this is an MC question. A queue is formed by 6 boys and 2 girls. If no 2 girls are next together, in other words, if the girls must be separated, right? No 2 girls are next to each other. That means the girls must be separated. We cannot put them together. Alright, how many ways the queues can be formed? Alright, there is a standard approach to do this. Now, this is how we do this, right? Okay, watch carefully. You have 6 boys and 2 girls, right? The boys, there's no limitation. So first we line up the boys. Alright, first we line up the boys. In this case, you have the 6 boys like B1 to B6. Alright, B1 all the way to B6. I don't know, who goes where, but there are 6 boys, alright, being lined up in there. So it can be boy 1, 3, 2, 6, 5, 4, I don't know, alright, or any other permutation on this range, alright. But then, to do that, to line up the 6 boys, we have 6p6 ways to line up the 6 boys. Alright, never mind the girls, just look at the boys first. We can do that with 6p6 ways. Now, and then here comes the highlight for this method. Let's look at the girls. How do you put the girls? Imagine we have like these tickets, alright, A, B, C, D, E, F, G. We separate, we put a ticket for each space between the boys and then one at the top, one at the end, right? So you have these 7 tickets, A, B, C, D, E, F, G. And then for each of these 2 girls, each one will just take 1 ticket. For example, the first girl will take, for example, take ticket B, alright? The second girl will take ticket E, alright? So what does that mean? That means G1 goes here, and then G2 goes here, alright? So between the boys, we put tickets between the boys, alright? So there are now 7 tickets. For each of these 2 girls, each one takes 1 ticket among these 7, and they just sit in that. They just queue up in that position. All right. So how many ways are there to put 7 tickets into the hands of 2 girls? How many ways are there to put 7 tickets onto the hand of 2 girls? There are 7p2 ways you can put the 2 girls. 7p2 ways, alright? To give 7 tickets to 2 girls, am I right? The 2 girls, they are not the same, so it's P, alright? There are 7p2 ways to give 7 tickets to 2 girls. Alright, so that means for each of these ticket giving, that's how you put the 2 girls. And in doing so, we guarantee that the 2 girls will never be adjacent to each other. We guarantee that the 2 girls will never be next to the same. So in other words, the solution is 6p6 for the boys, and then 7p2 to put the 2 girls in the 7 positions. This answer comes up to be 30240. Alright, so the answer to this question is C. Alright, that's how we do things that must be separated. We line up those that has no restriction. In this case, we line up the boys. There are 6p6 ways to line up the boys. And then between the boys, we find 7 positions, A to G in this example, alright? We put the 2 girls into these 7 positions. To do that, we have 7p2 ways to do that. So it's just a multiplication between the permutation for the boys and the permutation of the girls. Right, so this is how we do that. Now, alternatively, because there are only 2 girls, so we can invoke this idea. They are either together or they are separate, alright? So there is an alternate way we can do that, alright? The girls must be together means that the 2 girls are not separate. The 2 girls must be separated means that they are not together, alright? 2 is it only applies to 2, right? It does not apply to 3. Means that unless they are together, alright? Unless the girls are together. So we can do the equation. We can use this unless approach to do that, alright? Unless means 1 minus, right? So we take all the number of permutations. In this way, that would be 8 persons lined up together. So that would be AP8. Alright, subtract from it. That is unless. Alright, 1 minus. That 1 is not the 1. This is an AP8. And then we figure out how many ways are there so that the girls are together. Alright, we can look at the previous slide to look at how do we calculate must be together, right? So the girls are together. I prepare 1 box for the 2 girls. So altogether there are 7 boxes, right? 1 box for the girls and then 1 box for the 6 boys each. Alright. So here are the boys, alright? And then we have 1 box for the 2 girls. So to line up these 7 boxes, we have 7p7 ways to do that. Alright, and then if you open up the box of girls, you can also line up the 2 girls in 2p2 ways. Alright, so the girls are together. That will be this answer, 7p7 times 2p2. That is the number of ways that the girls are together. Unless the girls are together, so you take all possibilities, AP8, subtract that number, and the answer goes to the same 30240. Alright. But let me remind you again, this method, this second method only works because there are only 2, alright? If there are 3, then this method does not work. Then this method does not work, okay? So this is how we do things must be separated. Thank you.